All right, I need y'all to stop talking. Shh. Guys, I am recording, so we're gonna stop talking. I don't know how far we're gonna get in these notes. I'm just gonna work on them, and when we stop, we stop. Okay, so you don't have any homework in Canvas right now. I will post that after we get through with what we're doing. I didn't want to set it up and like feel like I have to rush it or anything like that. So this chapter, it's just listed. I'm hopeful that we can do 2 days of 10-1 and then 2 days of 10-2 or whatever, but that may not be the case. So it's in there. Dates may change. Just be ready for that. All right. So 10-1 is comparing two proportions. So sampling distribution of p hat 1 minus p hat 2. And again, I told you this is like Aaron and Pete's Jeep tours where we looked at the differences, and the same thing. That's what we're going to do. So we're going to choose an SRS of size N1 from population 1 with a proportion of successes P1. And an independent SRS of size N2 from population 2 with a proportion of successes P2. And I literally cannot tell you enough. Remember, every time we do differences, it's always addition. Make sure that you're doing that difference, and it is the same formulas. Everything is exactly the same, okay? We're just doing 2 instead of 1. So with the shape, when N1, P1, N1, 1 minus P1, N2, P2, N2, 1 minus P2, are at least 10. The sampling distribution of P hat 1 minus P hat 2 is approximately normal. What is this? What did I just do? What's this? Large counts. Mm-hmm. So remember, with proportions, we do large counts, right? Is everybody good with that? That's exactly what that's saying. So when we test random 10% large counts, now we have to do 2 different ones, okay? So we have to check the first proportion and then the second proportion as well. Got it? All right, so the center, the mean of the sampling distribution of P hat 1 minus P hat 2 is going to be P1 minus P2. And we already knew that. So every time we had the mean, we used it as our X bar, whatever, when we did that, our mu sub 0, all of those. So the spread, the standard deviation of the sampling distribution of P hat 1 minus P hat 2 is P1 times 1 minus P1 over N1 Remember we add them. Remember we add them. P2, 1 minus P2 over N2. But remember, we can only take the standard deviation if we're making sure it's independent, so the 10%. So remember, we check that 10% rule so that we can do the standard deviation, okay? So as long as each sample is no more than 10% of the population. You ready? Good. Put your phone down. All right. Your teacher brings 2 bags of colored goldfish crackers to class. Bag 1 has 25% red crackers and bag 2 has 35% red crackers. Each bag contains more than 1,000 crackers. Using a paper cup, your teacher takes an SRS of 40 crackers from bag 2. Let P1 minus P2 be the difference in the sample proportions of red crackers. So what is the shape of the sampling distribution and why? So we just talked about the shape on the front side. How do we tell what shape it is? We do the proportion, so, or the large counts rule for both proportions. So N1, P1. Our N1 was 50. I don't think it has the bag 1 on there. Hold on. Does it say? It doesn't. Bag 1 that took 50. Sorry. So 40 from bag 2 and 50 from bag 1. So I apologize if that's not on there. So 50 times 0.25 were red. And then N1, 1 minus P1 is 50 times 0.75. This first number is 12.5, which is greater than 10, so that one's good. This one is 37.5, so it's greater than 10. And then you have to check the other ones. So you got to do N2, P2. N2 was 40 from bag 2, and bag 2 had 35% red, which gives us 14, also larger than 10. N2, 1 minus P2, we have 40 and 0.65, which gives us 26. So if they're all greater than 10, it is approximately normal. And again, we already know this test. We're just doing 2 proportions instead of 1. B says find the mean of the sampling distribution and show your work. Sorry, this was the shape. This was the Y, all at least 10. Okay, so you know I answered both of those. B, find the mean of the sampling distribution. So remember from the front chart, that mean is the mu or mean of P hat 1 minus P hat 2. And we said that'd be the same thing as P1 minus P2. Our first proportion from bag 1 was 0.25. From bag 2 was 0.35. So our mean was negative 0.10. Notice, guys, that they defined what it is up here. So they said do P1 minus P2. Watch those because sometimes they'll flip them around. Okay, so just watch those. And then when you're working, if they don't define it and you flip it around, so like I told you about your one on your test about the spooky house and pirate whatever. If you gave it to me as pirate minus spooky, as long as you stated that somewhere, all your work could be the same. You may have a different answer from somebody else who did the other way around. Okay. So when you do differences, just make sure that you show where your difference came from. What did you subtract? Does that make sense? All right. So this one tells you that you have to do P1 minus P2. All right. This is it for part B. And then part C says find the standard deviation of the sampling distribution. And so we need to make sure what first. We're kind of doing things out of order. What do we have to have? What do we have to do? The condition, we have to do that first. What was the condition to be able to take the standard deviation? Okay, which one? 10%. So we got to do the 10% rule to be able to take the standard deviation. So the first thing you need to do is the 10% rule. So you're going to do 10 times 50. That was your first SRS, which gives you 500. It said that there are more than 1,000 crackers. So we're good. And the other one was 10 times 40, which is 400. And again, that's less than the population. So we're good to go there. So now we can take the standard deviation. So remember our standard deviation is P1, 1 minus P1 over N1. Make sure it's a plus. Even though we're subtracting, it's always a plus in the standard deviation or the variance. P2, 1 minus P2 over N2. Which is the square root. P1 was 0.25. So 1 minus would be 0.75. And our first bag had 50. Our second bag was 35%. 1 minus is 65%. And we only took 40 out of that one. When we put it in our calculator, we get this. Don't worry about the alternate example down there. When we have regular class, like if it were regular, I had those printed off and then we would go and do those. Will we do them at some point? Probably so. Okay. And the alternate example looks just like this. It's just different numbers. So it's not like you're really missing anything. You're just practicing more. Okay. We're going to flip it over. Conditions for constructing a confidence interval. So make sure that you know what we're talking about. We're making a confidence interval. So remember that's the one where it was like A comma B or whatever, 95% confident that the true proportion falls within blah, 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 blah. So this time it'll be the true proportion and the difference or whatever. Okay, so we're talking about a difference. So data from 2 independent random samples or from 2 groups in a randomized experiment. The biggest thing is just make sure it's 2 different groups. 2 different groups. So we do our 10%. When we take a sample, without replacement, and we check that N1 was less than or equal to 1/10 of the total population, and that N2 is less than or equal to 1/10, of the population 1 and population 2. And then your large counts, the counts of successes and failures. In each sample or group. That would be N1, P1, N1, 1 minus P1, N2, P2, N2, 1 minus P2. Are all greater than or equal to 10. So at least 10. All right, so the next one. Remember I told you we're just doing 2 sample this time instead of doing 1 sample. Everything is exactly the same, okay? It's all the same. So we're doing a 2 sample, that's the difference. And right here we're doing an interval. So just to remind you, a 1 sample for proportions was P1 plus or minus Z, and it was Z star times the square root of P1, 1 minus P1 over N, or P sub 0 over N, or whatever. So this was a 1 sample. 1 sample Z interval. Now we're doing a 2 sample. And again, it's for a difference. So you're going to start it with P hat 1 minus P hat 2, or if they define it the other way around, do the other way around. Plus or minus, still your Z star. Remember, your Z star is your confidence or your critical value. It comes from that 95%. Big fat square root of your P hat 1, 1 minus P hat 1 over N1. Remember, with variances and standard deviation, we always add. P hat 2, 1 minus P hat 2 over N2. So look at the formula. You should know it, right? Even right now, you should know it. So the only thing is, make sure this one is subtract, this one is add. Okay. Remember that this part without the Z star is the standard error. Okay, just as a reminder. So just like I told you, Z star is the critical value for the standard normal curve with C% of its area between negative Z star and Z star. Oh, C% confidence. Sorry about that. All right. So as part of the Pew Internet and American Life Project, researchers conducted 2 surveys in 2012. A first survey asked a random sample of 799 U.S. teens about their use of social media and the internet. A second survey posed similar questions to a random sample of 2253 U.S. adults. In these 2 studies, 80% of teens and 69% of adults, use social networking sites. Calculate the standard error of the sampling distribution of the difference of the sample proportions. Right here, it tells you which one to put first and what information does this value provide. So we're going to start there. So I'm going to write this down. Our adults are going to be our second. Our teens are going to be our first. Adults are going to be our second. All right. So what is our P hat 1? What's our proportion for teens? 0.80. What is our proportion for adults? 0.69. Remember that the standard error is that back part where it's the square root, it's the standard deviation, okay? So we're going to do P hat 1, 1 minus P hat 1 over N. So our first sample, our teens, were 799. This is always plus 0.69 and 0.31 over 2253. Do y'all have any questions about where any of that came from? Everybody good? This will give you 0.0172. So what information does this value provide? This is your standard deviation. Y'all remember how to interpret your standard deviation from a long time ago, okay? So that's all it's asking. If we were to take, sorry, ignore that. If we were to take many random samples of 799 teens and 2253 adults, the difference in the sample proportion that's what we were trying to find, the difference in the sample proportion will typically be, or will typically differ from the mean. That'll help you a little bit. Typically differ from the mean by 0.0172. So B, construct and interpret a 95% confidence interval for the difference between the proportion of all U.S. teens and adults who use social networking sites. So anytime we do construct and interpret, anytime you see interpret, that's going to be your state, plan, do, conclude. Okay. So in this one, we're going to state. And you're going to state your proportions and what you're doing. So P1, or tell what everything is. P1 is U.S. teens. Using social media. P2 was US adults using social media. And we want to estimate the difference with 95% confidence. The plan never changes. We want to do a 2 sample Z interval for proportions. I'm just going to put 2 sample Z interval. Then what else goes in your plan? Your conditions. Our conditions are random. Is it random? Yeah, how do you know? It was stated. What about your 10%? What do I have to do for the 10% rule? How many samples do I have? 2, and I have to make sure that those are less than a tenth of the population, right? So your sample times 10. So teens was 799. Pretty sure there's more than 7,990 US teens. Is everybody good? And then 10 times 2253, which is 22530. And there are definitely more US adults than 22,000. And then the last one is large counts. And this one just takes time. It's not hard. So 799 times your percentage, which is 0.80. And then 799 times 0.20. We get 639 and 160. So those are both okay. They got to be greater than 10. Then we have 2253 times 0.69 and 2253 times 0.31, which gives you 1555 and 698. So all of those are good. You're going to do the work in the next part. And again, don't worry about that alternate example. We'll get to that. Remember, we're doing p hat 1 minus p hat 2 plus or minus z star, and then all this stuff. P hat 2, 1 minus p hat 2 over n2. What was p hat 1? Proportion of teens. So what? 0.8. We did it at the top. So you've already defined them up here, way up here. Okay, don't forget that. 0.8 minus P2 or P hat 2. 0.69. 95% confidence has a Z star of 1.96. Good job. Remember, I told you it's good to remember that because that's typically what they use. And then fill in the rest of the formula. 0.80, 0.20 over 799 plus 0.69 times 0.31 over 2253.
That in part A, like if we drew the arrow down, would we not write all in?
You do not. And what if you write all this out and you've defined everything? So the only thing you hadn't defined is Z star. So somewhere if you put Z star, then you don't even have to show this work at all.
Okay.
You see what I'm saying? Okay. You don't even have to draw an error. Like don't draw that arrow.
Okay.
And then this gives you a confidence interval of 0.076 to 0.144. So what are we going to conclude? How do you conclude with your interval? Mhm. We are 95% confident. Captures the true difference in proportions of U.S. teens and adults who use social media, blah, blah, blah. All right, everybody good? Check their understanding. We're going to stop with this one. Got it? Everybody good? All right, so this will be the last one we do. Are teens or adults more likely to go online daily? The Pew Internet and American Life Project asked a random sample of 799 teens and a separate random sample of 2253 adults how often they use the internet. In the survey, 63% of teens and 68% of adults said they go online every day. Construct and interpret a 90% confidence interval. A 90% confidence interval. Okay. So the difference is the proportions, which is easy to work with, but then I have 90% confidence. So how do I do that? It's a different Z-star, right? We're right. So how do I do that? How do I find that different Z-star? Y'all remember how to do that? Okay, so let's see. Is it inverse norm? So we're going to try inverse norm. How would I figure out the area? 0.05, right? Okay. And our mean is? You leave it like that? Okay. Okay. Is everybody good with that? Okay. Perfect. So one more time. To get your Z-star, you do inverse norm. The area, 0 and 1, because we're doing Z, so we're standardizing. How do we get the area? 1 minus whatever our confidence is, divided by 2. 1 minus whatever our confidence is, divided by 2. So just as a reminder how to get that Z-star in case they give you something weird. Okay. We can always remember 95, and that's typically what they'll use. And then sometimes they'll throw in 90, so you need to make sure you know how to get that. All right, so a P1 minus P2 or P hat 1 minus P2. We're going to state, you're going to state all of your values and what they are. Okay, so we're going to do whatever P hat 1 is and whatever P hat 2 is, we're going to tell what that is. P hat 1 is the true proportion of teens online every day. And P hat 2 is the true proportion of adults online every day. State everything you already know. What is P hat 1? What is P hat 2? And then we already know Z star. What is Z star? And you can leave it 4.4 or 4.5. It doesn't matter, whatever you define it as, they will look at your work with that. Okay, so don't stress out about it. Our plan, we're gonna do a 2 sample Z interval. And why are we using Z? For p hat 1 minus p hat 2. What else do we put in here? So we start with random. Are they both random samples? Yes, and remember that they both have to be random, okay? Both of them have to be random. 10%. What are we gonna check? And we already did this, right? So I'm not gonna make you through, just put checks on them, we're good. And then large counts. And again, we've already done this, but we got to do it with the new proportions, okay? So this didn't change because they're the same sample size, but they do change proportions. So we have 799 times 0.63 and 799 times 1 minus 0.63. You can put those values or not, it doesn't matter. They're good to go. Then you have 2253 times 0.68 and 2253 times 1 minus 0.68. And all of these are greater than or equal to 10. So they all work. Okay. The numbers are 503, 296, 1532, and 721. Okay, all greater than 10. All right, what do I do now? So we have p hat 1 minus p hat 2 plus or minus z star, big fat square root, p hat 1, 1 minus p hat 1 over n1, make sure it's plus, p hat 2, 1 minus p hat 2 over n2. Okay, is everybody good? Put all those values in. P1 is 0.63 minus 0.68. Plus or minus, we found our z star was 1.645. Big fat square root 0.63, 1 minus 0.63 over n1 was 799 plus 0.68, 1 minus 0.68 over 2253. Gives you an interval of negative 0.083 to negative 0.018. Is everybody good? All right. So to conclude, what do we do? And I'm not going to make you write it all out. Confident that the interval captures, and you should write the interval in there. You guys know that. The true difference in proportions, blah, blah, blah. All right. I'll show you how to do it on your calculator now. So last thing I'm going to do is show you how to do it on your calculator. All right. So on the calculator, you're going to go to stat and your test. And it's gonna be a 2 prop Z interval because it's 2 proportions. Okay, so stat, test, 2 prop Z interval right there at the bottom, number or letter B. This number right here, this 503, came from 799 times 0.63. Okay, so that's where that comes from. Then your sample size for the first one was 799. Okay. The 1532 is from 2253 times 0.68. And then 2253 was your sample size. Okay, so that's where those come from. Our C level, our confidence level is 90, so 0.9. And when you put all of those in, you get your confidence interval. It tells you your P1, it tells you your P2, your N1, and your N2. All right, so just so you know how to do it on your calculators if you want to check it out. All right, any questions? All right, we're going to stop there. We only have a few pages tomorrow. And only the last 2 pages are really big. So we'll be all right. Lots of state plan due tomorrow. I'm going to stop sharing, stop recording. I will post